I'm Matthew Butkovic. I'm joined by my colleague, Dr. April Galyardt. Today we're going to discuss opportunities in the field of machine learning and what it's like to be a machine learning researcher. Welcome, April.
Hi, nice to be here.
So a basic question for you.
Okay.
When we say machine learning researcher, could you flesh out for me what machine learning is in this context? I hear lots of descriptions of machine learning and artificial intelligence. Maybe first let's detangle those two terms and then talk about what it means to be a researcher focused on one of those things or both of those things.
Okay, so part of the reason that those terms are so tangled up is because it lies at the intersection of a lot of different communities. And so what a computer scientist says when they mean AI or ML, what they mean is going to be different than what a statistician means, is going to be different than what a journalist means. And so that's where a lot of that confusion comes from. So within computer science, the definitions are reasonably well set, where AI is doing a task that normally requires human intelligence, having a machine be able to do that task. So an example would be like Google Translate. That is a task that normally requires some pretty serious intelligence, and the machine's able to do that automatically. Now, underlying a lot of artificial intelligence is machine learning. Machine learning is the guts that makes AI go. And this is actually where the definitions get a little more fuzzy, because within computer science, you'll often hear people talk about machine learning being extracting information from data so that the machine can program itself. So it extracts the information, and then there's an element of automation. And so that is clearly a piece of AI. On the other hand, there's a lot of modern technologies, and statistics has been extracting information from data for, almost 2 centuries. And so within the statistics community, it's not just the extracting information from data, it's using a particular set of tools, focusing on optimization, the more modern tools that require high computational power. That more characterizes machine learning. And so that's where a lot of the confusion comes from.
Okay. And I'm hearing that it's sort of inherently an interdisciplinary effort.
Absolutely.
You mentioned computer scientists and statisticians. Are there other professions or domains that we would often draw on when thinking about machine learning?
Yes, some of the founders of the AI field were Herb Simon and Alan Newell. They were big in psychology, and they were able to give AI a jump start back in the 50s. They were here at Carnegie Mellon. But by drawing on their cognitive science background, and in fact, a lot of cognitive science came out of trying to get computers to behave like humans and abstract the human behavior to be able to program a machine. So psych is one. Already mentioned statistics. Robotics uses a lot of this. And so where you can have an AI that's not a robot, so we'll sometimes disembodied AI. Again, Google Translate is a good example. But you can also have, if you want to build an autonomous robot, then AI is clearly a big piece of that.
Sure, so it sounds like AI and ML are becoming pervasive and sort of ubiquitous, or will be. So Google Translate, autonomous vehicles, and then certainly there's a host of sort of commercial uses and industrial uses that most folks wouldn't see. Can you describe here at the SEI generally the types of projects in which we're asked to apply our expertise in machine learning or artificial intelligence?
Oh, there's a huge range. They range from, some of the projects are in disaster response. And so if I have 2 photographs before and after a natural disaster, like a hurricane or a flood or a fire, something like that, can I identify the most damaged areas quickly so that I can send out my first responders and my search and rescue teams most effectively and most efficiently, so I'm not sending them to the wrong places. So that's an issue of national import that we've got a team working on. We've got other teams that are working on building tactical AI and ML that could be used in the battlefield. Those are very prototype systems right now. And then we have others that are looking at applying it in cybersecurity. For example, detecting and identifying malware, detecting and identifying different kinds of malicious activity on a network. That's just software related and DoD related.
So it's very, very broad.
It's a tool. And so in the same way that your phone is a tool and it's changed everything, machine learning, maybe think of it as a hammer we haven't quite found all the uses for yet.
That is a great way to describe that. So a more practical question perhaps about the path that folks take to a career in machine learning and artificial intelligence, and maybe more specifically the sorts of backgrounds that we see here at the Software Engineering Institute. Can you describe the typical profile of someone that's doing this sort of work at the SEI?
So we have here, and this is actually kind of industry-wide, there's really kind of three pathways that people have taken into machine learning and AI right now. One of them, is the one I took and that several of my colleagues here have taken, is we're statisticians. We know data, we know how to manage data, we know how to pull information out of it, and designing the algorithms and understanding the algorithms and the mathematics around that, that's really our specialty. And then we have a lot of people who've come more out of a computer science background. And computer science programs around machine learning and AI have changed pretty rapidly in the last 5 years. So people who've studied that in school, they're starting to build better data science programs and have more of an understanding of data and bringing the statistics and the heavily data management, data architecture, those programs. And we have a fair number of people who've come out of a computer science background and come into machine learning that way. And then there's a third path, which is all of these tools, you're applying statistics and machine learning to a problem. And so you have your subject matter expert who's really an expert in the problem, and they've picked up some of the machine learning tools that they need to solve that problem. And we've got a couple of those people, and I think the field at large is going to see more and more of those people.
So in that description, April, I think I'm hearing that there's both researchers and then engineers. And there's sort of a place for both.
Absolutely, absolutely. Yes, thank you for clarifying that.
But I also think that when I think about engineering, any engineering discipline follows in the heels of some invention, innovation, or new technology.
Right.
Given that all of this is so new collectively, or I guess the application of it, it seems to me that there's enormous potential to kind of make your mark as both a researcher and an engineer in this field.
Yes, and we have a couple of research projects right now. One of the things that SEI is famous for and has historically made it is solidifying the field of software engineering as an engineering discipline and establishing the practices. And that same kind of work in terms of what are the engineering patterns, what are the architecture tactics that we can use, that is work that we're working on. We've got a couple of research projects along those lines so that the engineering of AI systems, once it gets out of the researcher's hands, because right now we've got a lot of the academics and people in the university are building new algorithms, and that's fantastic, and they're great, and I love me a new algorithm. But a lot of what is useful in a practical everyday setting is not the cutting edge stuff. I mean, the cutting edge stuff is super cool, but the stuff that to the academic seems old hat is still new in practice. But there's a lot of engineering, and particularly pipeline engineering, from collecting the data and managing it and processing it and setting up the algorithm and deploying it. There's a ton of engineering work, and setting up those tactics that's something that we're working on.
Excellent. So one of the problems I hear mentioned in the artificial intelligence space, and I think also you could apply the same comment to machine learning, is this issue of explainability. And the way I'm having this expressed to me is that if we're going to automate a process, something I often work in evaluating things that are critical infrastructure, that are safety sensitive and life safety important. If we're going to automate some specific task or process, how do we have sufficient visibility into what is often described as a opaque box of ML and AI? Can you maybe speak to the explainability problem and how we are addressing that in our work here at the SCI?
Yes, and I think it might be useful to first draw a distinction about when explainability is most important.
Okay.
So, to draw an analogy, so if I ask you who is the best judo player in the entire world, you don't, I imagine, know anything about judo.
Yeah.
And I could not name this person off the top of my head either. But there's an objective measure. We can go and look. There is a current world championship who has thrown everybody else. So we know that he's the best because he won. And there's an objective measure of that. On the other hand, your car mechanic tells you that, well, you need to get this fixed and fix these 3 things, and then it'll run better. And if your car was making a sound and the sound goes away, you have a little bit of evidence, but you don't have as much. And so you need a little bit of explanation there to build that trust.
Sure.
And then you can take it, you've got a climate scientist who's saying, well, in 2,000 years, this is going to happen. You have no check whatsoever. And so those 3 situations highlight how much feedback we're getting.
Okay.
So if we're in a system and we've got an algorithm that's predicting something and I get immediate feedback on it being right or wrong, such as Google. Google is predicting what you're going to click on, which ads you're going to click on. And they get very immediate feedback on you did or you didn't. And so it's very easy for them to check their algorithms, and they don't necessarily need a whole lot of explainability about why you clicked that ad. The black box works. The shorter term, the medium term decisions, if I am predicting that there's going to be some sort of network event in the next month, I might want some explainability on that.
Sure.
But it's kind of medium term. I get a little feedback. I can check on the black box. If I am predicting, to use an example that's going, these systems are deployed, recidivism. So predicting whether somebody who's convicted of a crime, if I give them probation, whether they will recommit. The machine learning system makes a prediction, and it's years before you get feedback on whether or not that prediction was correct. And so you better have, that last case needs to be really explainable. And so separating those cases and what kind of explainability you need, that's, thinking about that is a huge piece of the work.
Can you describe sort of our role or how you anticipate we may assist with that question?
Yeah, so I've been called on to give a couple of briefings to different people about that. I'm talking with people in acquisitions, people who buy these products about what they need to pay attention to, and the whole problem is made much more difficult by the problem of definitions that we mentioned at the beginning, because of, for some people, if they're using one set of definitions, they're going to be like, well, I used this logistic regression and I made a prediction and now there's an automated decision, so that's an AI. To clarify, logistic regression is a mathematical method that's been common in statistics for, I don't know, I want to say 75 years
75
plus.
Years, okay.
It's not new. And it's not as computationally intensive as a lot of the new methods. And so, a lot of us would look at that and go, that's not AI, that's not machine learning, that's old stuff, you just automated it. Whereas other people are like, no, it's AI, it's automated. And
Well, there's sort of the trade show definition, and then there's the scientific definition?
But even just different community, but yeah, sure. that first, that's definitely like the trade show definition. And so, but more than what algorithm people used, I think that focusing on that piece is a little beside the point, because it's the issue of trust. And how do I know how you cross-validated your results? If you're telling me you're 90% accurate, well, that's 90% of what? Is that 90% of all incidents, or is that 90% of the data and the incidents that you already detected? Or so
A
Yes.
question for folks, and certainly if you're watching, if you're interested in roles here at the SEI, there's a link that will take you to the open positions that we have, not just in this field, but in others. Could you describe sort of, if someone's aspiring to do machine learning and AI in the software engineering or cybersecurity context, what types of education would you recommend for them, the types of courses? I know we've said you can come from the psychology perspective or the statistician perspective, but generally, is there an emerging canon of things that folks know in this field?
Yeah, so there's a couple of, so the number one thing that is an understanding of basic stats, like the stats 101 stuff, the idea of a sampling distribution, and the idea that tomorrow's data will look a little bit different, but somewhat similar to today's data, and that those differences are predictable, at least under certain assumptions. That idea is key to everything, and so the foundations in that statistics class, and this kind of goes to 5 years ago, I think a lot of the data science and programs coming out of computer science didn't necessarily have that requirement, but they're starting to realize how necessary, and you're starting to see that requirement more. And coming again from the statistician side, a lot of statistics programs don't always require enough programming.
So there is that cross-pollination.
Right, and so some of the basic statistics ideas, the more data management skills, we're actually, data architects are one of the jobs that we think are going to be growing. So this is somebody who can set up the pipeline, who can make sure that the data that comes in gets cleaned. So somebody else will be cleaning it, but managing all of that pipeline and making sure it's flowing and making sure everything's feeding back. Just being a database engineer isn't enough to cover all of that.
What I really like in your description is you're describing skills that are highly generalizable and fungible. So you're applying it to an AI ML context, but it's also relevant and important in many other places. And I think there's a real power in that.
Right. And it's one of the things that I think is most valuable about going through an actual program and the courses and the degrees that universities offer. You can find a lot of resources online in terms of, here's how this algorithm works, here's how this algorithm works, here's the code, just run it. And you see people do that, like, oh, data, throw it in a box, look. Oh boy, that does not, but having these things organized into a program where you understand the trade-offs that you're making and you know why to choose one algorithm over another algorithm, those sorts of things. Knowing how to make those choices and being able to defend those choices, that's something we like to see.
Yeah, and I think that doing this in a risk-informed context is really important. I think that's where at the SEI, combining software engineering with new cutting-edge technology, with the fundamentals of cybersecurity risk management, there's much like your description of the interdisciplinary approach that we have to ML and AI, I think we apply a similar focus in our work kind of writ large.
Yeah, I think that's absolutely true. And whether you're working on the cybersecurity aspect or you're building something that's a little more tactical, yes, absolutely. We're always doing interdisciplinary work.
So in conclusion, April, if you could give one piece of advice to folks that are looking to either enter this field or maybe recast themselves as AI, ML researchers, engineers, maybe this is a tough question, what would that advice be?
One piece of advice.
It sounds like brush off your stats book from undergrad. You probably thought about it in a long time, potentially, if you're not a statistician, right?
I think the reason that you want to brush that off is because there's so many choices that have to be made all the way along the data analysis pathway, that being able to examine and defend those choices and being able to explain them, the decision, just to make it a little more concrete, when you're analyzing text, the words are you're analyzing the words. Well, you can reduce the number of words you have to process and reduce your capacity if you take out all the, of, and, all the little words. how many words do you take out? Do you stop at just? Do you stop at only? Do you take out the top 100 words? Do you take out the top 200 words? And that's just one choice. Yeah. And so being able to defend all those choices all along the way and explain them, that is a hugely valuable skill.
So it sounds like no matter sort of which path you take academically or educationally, if you have a curiosity and you're a critical thinker, these are the things that are sort of essential for this field.
I think that's fair to say, yes.
Well, thank you so much for the discussion today about AI and ML. And if you're interested in positions or careers here at the SCI, please follow the link listed below.